Good morning, class. We'll continue with chapter 6 today. Chapter 6 is data models. Uh, this one also is a short chapter. Consists of relationship, graph databases, and schemaless database. So the learning outcome will be at the end of the lecture, student will be able to explain the embedded and reference relationship, describe the graph database, describe the schemaless database, compare the NoSQL data models, evaluate the suitability of NoSQL, and assess trade-off between embedding and referencing NoSQL documents. First, relationship. In traditional relational database like MySQL or PostgreSQL, relationship are key. You have probably heard about terms like one-to-one, one-to-many, or many-to-many relationship. So these relationships define how the table interact with each other using foreign keys. Okay, foreign key present with primary key as well. Okay, but in NoSQL, things work a bit differently. The types of relationship in NoSQL. Let's break down how the relationship are handled in NoSQL database. First one, embedded relationship. In this model, related data is stored together in a single document or a record. Example, imagine a blog post with comments. Instead of having a separate table for comments, you could store all the comments as an array inside the blog post document. This example we have done during our practical time. So the pros is faster read because all the data in one place. Okay, the con is can become unwieldy if the embedded data grows too large. If too large means it's not nice to see and read. Okay, second relationship is a reference relationship. Here the related data is stored in a separate document, and references similar to foreign keys are used to link them. Example, a user document might have a user ID field, and a separate order document might have a reference to this user ID that has been created previously. Okay, the pros is keeps documents smaller and avoid duplication, and cons is required multiple queries to fetch related data, which can be slower. Third one is hybrid approach. When it's come to hybrid, it's a combination. Okay, many NoSQL databases allow you to mix embedding and referencing based on your use case. For example, you might embed frequently accessed data like user profile, but reference less frequently accessed data like transaction history. Okay, so these are the types of relationship in NoSQL compared to SQL relational database. Number 6.2, graph databases. What are graph databases? Now let's talk about something really cool. Graph databases, if you have ever wondered how Facebook suggests friends or how LinkedIn recommends connections, the answer lies in graph databases. It's actually networking. So the graph database store the data in nodes and edges. So the nodes represent entities like people, product, and location. Edges represent relationship between those entities like friendship, purchases, and routes. For example, friend suggestions in Facebook is actually based on the mutual friends that you have with that particular friend. Let's say you have 10 mutual friends, Facebook automatically will suggest to you, okay, you might have this friend, okay, there is a new suggestion for you, something like that. So the beauty of the graph databases is that they are optimized for querying relationship. For example, finding the shortest path between two nodes or identifying the cluster of interconnected nodes is incredibly efficient. Here are some examples where graph databases are showing. Social network, modeling connection between the user. Number 2, recommendation engine. Okay, finding patterns in user behavior to suggest products or content. Like, whatever you think that you search in Shopee or Lazada, sometimes it come out in Facebook. So based on your previous history, it will gives you suggestions. Fraud detection. identifying suspicious pattern of transaction or interactions. And last one is network topology, mapping out IT infrastructure or transportation network. So these are some example. Next, popular graph databases. Some of the most popular graph databases include Neo4j, the most widely used graph database known for its Kuiper query language, okay, CQL. Amazon Neptune, so a fully managed graph database service, and ArangoDB is a multimodal database that supports graph documents and key value pairs as well. So these are some popular graph databases. Example 6.3, schema-less databases. We already come across about schema-less, and I already explained multiple times about this. Okay, come again. Let's see what does it here the schema-less databases means. Finally, let's talk about one of the defining features of many NoSQL databases being schemaless. Okay, we are aware of it. So schemaless database, you don't need to define a fixed structure for your data upfront. Instead, each document or record can have its own unique structure. For example, in MongoDB collection, which is a schemaless, one document might look like this. For example, name, age, and hobbies. Okay, that JSON format. Okay, and another document in the same collection might look like this: name, profession, and project. So you can see the attribute is different. Name is present here, age and hobbies, but in this case profession and project. Notice how the second document doesn't have the age field and the first document doesn't have the profession field. So that's perfectly fine in a schema-less database. Advantages of schema-less databases, as we know, that's flexibility. You can easily adapt to changing requirements without redesigning your database. You don't have to redesign your database. You can just adapt and change or modify. Rapid development. Developers can iterate quickly without worrying about strict schemas like relational database. Okay, handling unstructured data. It's ideal for applications like IoT, Internet of Things, social media, or analytics where the data formats vary widely. Challenges of schemaless database. There are some challenges when it's come to schemaless databases. First of all, data consistency. Without a fixed schema, it's harder to enforce consistency across records. Second is query complexity. Writing queries can be more challenging when data structures vary. So documentation, the third one, is up to you to document and understand the implicit schema of your data. So these are the challenges of schemaless database. When you're supposed to use schemaless database? So schemaless databases are perfect for prototyping and early stage development, application with highly dynamic or unpredictable data, situation where the speed and flexibility are more important than the strict consistency. When it's come to consistency, then it will go for relational database. They won't come to schemaless NoSQL. So as a summary, we already learned about relationship, graph databases, and schemaless databases. So hope you guys got some idea about graph databases, relationship, and the schemaless database. Okay, before end up, I will share an assessment in Author. After watching this video, you guys can try to do the assessment activity and submit in Author as well. Thank you.